This tutorial shows you how to decide which results from structure to use. Structure is a program commonly used in population genetics. It generates multiple sets of results with no clear guidance as to which ones to go by. This tutorial shows you how to choose. This tutorial uses the results created by another tutorial called How to Run Structure. See the show notes for this and other videos about structure. This tutorial assumes you are using Ubuntu Linux version 20.04 as your operating system. If you do not have Linux, you can emulate it on your Windows or Mac computer for free. See the show notes for details. In fact, I am emulating Linux right now on my Mac computer using VirtualBox. Speaking of which, I have a VirtualBox virtual machine pre-configured with the software I will show you today, as well as other population genetics and ecological niche modeling software. See the show notes below for step-by-step instructions to download and hook up this virtual machine within your Windows or Mac computer. This tutorial assumes you have RStudio installed on your machine, which also requires R to be installed. Furthermore, this tutorial assumes you have several different R packages installed, some of which are challenging to install on Linux. I have a tutorial that will fix these problems entitled How to Install the R package pegas under Ubuntu Linux. While we will not be using the R package pegas, installing that package and the other software required for it fixes most of the problems you would otherwise encounter when trying to run this tutorial. See the show notes for details. Of course, if you use the most recent version of my pre-configured virtual machine, you will find the software already installed and configured, and you'll be ready to proceed without watching any other tutorials. To get started, open a web browser. Visit my website, joshbanta.com, and click on Tutorials. Scroll down until you find How to Decide Which Results from Structure to Use. Click on Files Needed for Tutorial. Wait for the website to finish loading, and then press the download button and select Direct Download. You may now close your web browser. Now I want to show you something. Open up File Explorer, which on my virtual machine is pinned to Favorites, or which you can search for below. If you're using my virtual machine, navigate to the bin folder, or navigate to wherever your folder is where you've been running structure. In my case, that folder is called Console. The issue here is that you may have run structure before on some other data. You don't want to lose the results from the last time you ran structure every time you're running structure again. You want to be able to save those results from when you ran structure on one particular data set forever. So here's what I recommend you should do. These steps I'm recommending for you are if you were using your own data and you're using this tutorial to help you, but you're working with your own real data, not sample tutorial data, and you don't ever want to lose it. If you are on a Windows machine or have a Windows type mouse, right-click. If you are on a Mac laptop, push down on the trackpad with 2 fingers and select Copy. Then come to this space over here, which is your desktop. Right-click if you are on a Windows machine or have a Windows type mouse, or push down on your Mac trackpad with 2 fingers to pull up the drop-down menu where you select Paste. Now you have a copy of your structure folder which contains your previous structure results on your desktop. Or you could put this folder in some other location where you can save it forever. To do that, if you are on a Windows type computer with a Windows type mouse, right click, Mac trackpad, push down with 2 fingers, select rename, and call the folder something that will remind you about what sort of data you were running the structure analysis on. Let's say that we ran this on the plant Arabidopsis. We would type in Arabidopsis and click, and let's say Arabidopsis structure results, and then we would click rename. Now we have a copy of when we ran structure on this Arabidopsis data, and we have that copy forever, separate from the folder where our structure program lives. Now we can safely work with this data without messing up structure, without messing up any other results we have from any other data sets when we ran structure before, because presumably you will have also copied out this console folder and pasted it somewhere else every time you've run structure, so that you have those results saved somewhere else as well. This is what you would do if you were using your own data. But because we're going to be using sample data for this tutorial, just know that that's what you should do if you were using your own data. Here's what I want you to do for the purposes of this tutorial instead. So let's get rid of this folder. Just move it to the trash. Remember, it was just a copy. We still have the original over here. Go to your Downloads folder. Here we have the file that we just downloaded from my website. Double-click on it. This folder is contained within a compressed zip archive so that it takes up less space. In this archived format, the files within this folder are not accessible to the computer. We need to uncompress this folder out of the zip archive. Let's uncompress this folder to our desktop. To do that, move back to your File Explorer. You can either reopen it, or if you still have it open, you can click on it. Then navigate to your desktop. Go back to the Archive Manager software, select the console folder, and drag it to your desktop. Now you can close the Archive Manager software. And let's rename this folder to something more meaningful so that we'll remember what it is. Right-click for a Windows machine, Windows type mouse, 2-finger push down on a Mac trackpad, scroll down to rename, and we'll call it Arabidopsis structure results. Push the green rename button. Now we need to move some files around. If you are doing this tutorial following what you did on my previous tutorial, then when you ran structure, all of your structure results files were there in the same folder with the program structure and everything else. But we need to take those structure results files and put them into their own separate subfolder. So double-click on this folder. Here are our structure results files. This is the way that I had you name them in the previous tutorial. If you generated the structure results files on your own using different names, they would be different here. But whatever the names are, you want to highlight all of those files. But first, let's actually make a subfolder to put those results files into. Select the drop-down menu of the folder name from the top of the File Explorer window, and then select New Folder. Let's name the new folder Results. Click Create. Now we're going to take all of our results files. Highlight the first one, and then you can go all the way down with your mouse to the last one, and you can hit the Shift button and then normal click to highlight all of them. Or you could highlight all of these manually in some other way. The point is to take all of these files and either one by one or by highlighting them together, drag them into the results subfolder. Next thing to note, I have added an R script into this folder. if you were working with your own structure folder, following my tutorial before, but if it was based on your own data, and you were just trying to go ahead without using any of the tutorial data, you wouldn't have this R script in your folder. In that case, what you would want to do is download the sample data for this tutorial, uncompress the data, take this R script file out, and copy it into the folder that contains your actual data. The point is, you need this R script in the folder where your results are located. You need this R script in the folder where your results are located, but your results will be located within a subfolder within that folder. So you need the R script outside of that folder, and then outside of that folder that has your results. And inside there, you need the subfolder called results that has only your results files. And with that, we can proceed. Double-click on the R script. This will open up RStudio. The first thing we need to do is set our working directory. Click on Session, Set Working Directory, choose Directory. For the working directory, choose the results folder that has only the results files in it. In case it's not pulling up for you, remember we put that folder on our desktop in the Arabidopsis structure results folder, so double click on it. There's the results folder. That's what we want our working directory to be. Don't double click on it, just click on it once, and with it highlighted, click Open. Next, you need to copy the information about our working directory. So that information was printed out down here in the console window. Highlight it. I'm going to highlight it without the quote marks and add the quote marks myself. Then, on a Windows-type mouse, I will right-click. On a Mac trackpad, I will two-finger push down on the trackpad, and I will select Copy. What you need to do is put that path into the R script right here. I will show you how. Delete where it says Put Path Here. Add a quote symbol. Notice it adds the other quote. Then, carefully keeping the cursor where it is at, on a Windows mouse, right-click, on a Mac trackpad, push down with two fingers, and then choose Paste. Next, save your work so that you don't lose the changes you've made to the script. Click on the picture of the disk. Now we are ready to run the script. Highlight lines 5 through the end of line 21. There's multiple ways to do this. The fastest way is to put the cursor at the beginning of line 5, then without clicking on anything, hit the Shift button when you get to the end of line 21, and then click. You could also do this manually by highlighting lines 5 through 21 with your mouse in the usual way. Click Run. The appearance of this graph on the side shows that everything ran properly. I will show you how to interpret these results, but first let's save them. Click on the drop-down menu for Export and click on Save as PDF. Never use Save as Image because Save as Image saves in a low resolution that is not suitable for publications. Choose the directory where you want to save your results. We're going to just keep them in that results folder. And we'll name them K groups results.pdf. Click on Save. You may now close RStudio. click on Don't Save. It's asking about the console window down here, which is just the output of R as it's running your script. As long as it's not asking you about saving your script, you can click Don't Save. If it's asking you about saving your script, that means you've made changes to your script that you forgot to save. Click on Don't Save. Let's look at those results. Let's go into the results subfolder. By the way, if you ever need to rerun that R script, it won't run as long as this file, and this file are in the folder. When you run the R script again, the only things that can be in this folder are the original structure results. So if you're getting an error when you try to rerun the R script, it may be because you already had some of these files showing up in the folder. Double check this folder if you're rerunning it to make sure that these files are not in there. But assuming you want these files to be in there because you're finished running the R script and everything has worked fine, you'll have these files in here and you're good to go. Let's click on the one kgroupsresults.pdf. Let's enlarge so we can see the figure at a larger scale. This figure is something that would go in the supplemental figures of your manuscript or of your thesis or whatever paper you are writing. It's not formatted in the most beautiful way, but it's formatted well enough for a supplemental figure. This figure was made using the R package pophelper. So be sure to cite pophelper in your thesis or in your manuscript. You can see the show notes for this video for suggested text you could use to explain the figure and for the citations to use to go along with the figure. Here's what you've been waiting for. Here's how to choose which sets of results from structure output are the ones you want to go forward with. There are two places to look. One is here in this figure, and the other is here in this figure. Let's start by looking at this figure here. This shows the average negative log likelihood of the results for each of the different numbers of inferred ancestral groups. So this is for 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 inferred ancestors. These are averages across the 3 replicate runs that you performed for each number of inferred ancestral groups, or however many replicates you performed. These bars are some sort of error bars, perhaps it's the standard errors. What you want to look for here are the results that maximize the negative log likelihood. So you want to find the highest negative log likelihood. It's hard to tell on here. Another thing to keep in mind is if the negative log likelihood levels out or starts dropping, you want to go to the point where the negative log likelihood reached its peak and then leveled out. So overall, it's looking like our best negative log likelihood is going to be at k equals 1, k equals 2, k equals 3. It looks like it's going to be at k equals 3 or perhaps k equals 4. It's kind of hard to tell if this is leveled out or if k equals 4 has increased a little bit. This is where this other graph down here in the bottom right-hand corner comes in. This shows you the change in the negative log likelihood with an increase in the number of inferred ancestral groups. Now, the x-axis is a little bit frustrating because it's showing 2.5. And of course, we never had 2.5 ancestral groups. So the best thing to do is to just count the dots. It starts with k equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, assuming that, like me, you started with k equals 1 and you went to k equals 10. Now, in the graph down here, it doesn't start with k equals 1. It starts with the change from k equals 1 to k equals 2. This is the change from k equals 2 to k equals 3. This here is the change from k equals 3 to k equals 4. Look at how big this peak is. This delta k peak shows you the optimal number of inferred ancestral groups. And that was when we went from 3 to 4. We got this peak. So 4 ancestral groups is the optimal number. So you want to find a peak in this graph, and you want to see what that peak corresponds to. This peak corresponds to going from, let's see here. So this is going from 1 ancestral group to 2 ancestral groups. This is when we increase from 2 ancestral groups to 3 ancestral groups. This is when we increase from 3 ancestral groups to 4 ancestral groups. So the answer is 4 ancestral groups. 4 ancestral groups is the optimal number of ancestral groups for us to use moving forward. You can now close the document viewer. I want to show you another thing. Those results from those graphs we also have in a numeric format in this file called ivanomethodstructure.csv. So if you ever want to know the precise numbers that correspond to the dots on those graphs, double-click on this file. You may have an old document that's still remembered by LibreOffice, or this warning may not come up. If this warning does come up, click on Discard, click on Yes, click on Cancel. When you come to this screen, click on OK. And here are the same results that you saw in those graphs. So there are those results from the lower right-hand corner. The results from that part of the figure that said delta K. And this shows you the delta K values for every number of inferred ancestors. And you'll see here at inferred ancestors equal to 4, which is at row 5. You'll see that that's where we got that huge peak in delta K. Some of these other columns correspond to, I think, some of the other figures you saw in that 4-part graph. I don't know exactly how to match them up, but here are some raw numbers you can use to match up to those graphs that you got printed out by the R script. All right, let's go ahead and close LibreOffice. So now what? Now we've discovered that the best results are the ones for 4 ancestral groups. But notice that there are 4 different runs for 4 ancestral groups. So which sets of results do we use from this set? There's 3 different replicates for 4 ancestral groups. We know that 4 ancestral groups on average was the best. Which one should we use? I choose the one that has the middle of the negative log likelihoods. Let me show you what I mean. Let's look at k4run1.txt. And if we scroll down to line 50, we see negative 37,796. Let's look at run 2. Let's go down to the same part. We see negative 30,801. So that's a little more. A little more negative. Now let's look at the third one. $37,788. So this one was in the middle of those other two numbers. And that's the one that I go for. I go for, out of those three negative log likelihoods, which number is in the middle. So from this set of three replicates, I would go for k4 run 3.txt, because the negative log likelihood of that particular run for 4 ancestral groups had a negative log likelihood that was in the middle of the numbers for the negative log likelihoods for the other two runs that had 4 ancestral groups. One of those other runs had a negative log likelihood that was larger. Another one of those runs had a negative log likelihood that was lower. So I go for the run that had the negative log likelihood in the middle. Your results may be different from mine. So for you, instead of it being run 3, it might maybe run 2 or run 1, because every time structure runs, it runs differently. But you want to pick the one out of that set of replicates that's in the middle of that set of replicates. So even though it's 4 ancestral groups, which run is in the middle? Another thing to keep in mind is that your graphs that we looked at may actually be different. You may find that there's a different number of inferred ancestral groups that's optimal when you ran structure, because structure runs differently every time, and we didn't have a lot of iterations after the burn-in period. So structure may not have found the optimal solutions, but you would go with whatever, according to the output from that graph, showed you was the best number of inferred ancestral groups. In my case, it was 4. Then you would look among the 3 runs for that number of ancestral groups, and you would find the file from that set of 3 runs for that number of inferred ancestral groups that had a negative log likelihood that was in the middle of the two extremes of the 3 negative log likelihoods from that set of 3 runs. Now what? Now we know which file to use, which has our results. In my case, it would be this file right here. But how do we get these results into a format where we can visualize them easily, interpret them easily, and publish them in a thesis or in some sort of a manuscript for publication? For that, I have another tutorial for you to watch. It's called How to Most Easily Visualize the Results from Structure and Make a Publication-Ready Figure. The link to that tutorial is in the show notes below.